Hello, everybody. I'm just going to walk you through a couple of examples of what we expect you to do when we ask you to graph quadratics in factored form. Now, we've talked about in class graphing when they're in standard form. We've talked a little bit about graphing form. Now we're going to talk about factoring form. And what we really want you to see is how all of these different forms have a lot of similarities to them. The processes are very similar. So I want you to find four things as you're going through these problems. I want you to find your y-intercept, your x-intercepts, your line of symmetry, and ultimately your vertex. And those are the things we're going to use in order to graph. So let's get started. For our first example, we have y equals x minus 3 and x minus 6. Do not feel the need to go and use your generic rectangle to multiply these back out. I want to deal with them exactly the way they are. Now, when we're going to find our y-intercept, remember that your y-intercept means you are solving for y when your x is 0. You want to make sure that those points are right on that y-axis. So all we have to do is plug in zeros for our x's. So I'm going to go and plug in zeros for both of these x's. Okay, then I'm just going to do the parentheses next. I'm going to follow my order of operations. So 0 minus 3 is just negative 3. 0 minus 6 is just negative 6. And then all that means is I'm going to multiply those together. So my y equals positive 18. A negative times a negative is a positive, Miss Spencer. Okay, but again, remember, I'm asking you for what is your y-intercept. The fact that I solve for y equals 18 is not necessarily my y-intercept until I write it as an ordered pair. So remember, when I plugged in 0 for x, I got out 18 for y, making my y-intercept 0, 18. Okay? The next thing that I want you guys to do is find your x-intercepts. Now remember your x-intercepts. Now we are solving for x when y equals 0. So we're still going to start with the same problem up here. And now we're just going to plug in 0 for y. So for my x-intercepts, I'm going to have 0 equals x minus 3 and x minus 6. Okay, and this should look very familiar. Now we just have the zero product property. So when we're using the zero product property, I want you to actually write out, we have x minus 3, I'm going to set that equal to 0, and we have x minus 6, I'm going to set that equal to 0. Now I know a lot of you guys can do these in your head, but I want you to show your work a little bit. For this one, we're going to be adding 3 to both sides. For this one, we're going to be adding 6 to both sides. So for this one, my x is just going to equal 3. And for this one, my x is going to equal 6. Now remember, 3 minus 3 is 0. So when I plug it in here, this whole term is 0. When I plug in 3 over here, I'm going to get negative 3, but that's okay because remember, as long as one of these is 0, they both equal 0. So 0 times negative 3 is still 0. And again, this is all fine and dandy that you've solved for x, but I want to write them as x-intercepts. So my two x-intercepts are going to be 3, 0 and 6, 0. Okay, now that we have our x-intercepts, the next thing I wanted you guys to solve for was your line of symmetry. Now, some of you guys like plotting out your two x-intercepts on your graph. You can do that and find the exact middle for your line of symmetry. I'm going to do it algebraically this time. So for my line of symmetry, if I want to find the exact middle of my two x-intercepts, what I'm going to do is I'm going to add my two x-intercepts together. I'm going to add the 3 and the 6 together, and then I'm going to cut it in half. That's how I'm going to find the middle. So 3 plus 6 is 9. I'm going to divide 9 by 2, so I'm going to get 4.5. So this one's not an exact number. That's okay. Your line of symmetry can be wherever it needs to be. But again, your line of symmetry is a vertical line that is cutting your parabola in half. So vertical lines always have the equation of x equals. So in this case, my line of symmetry is x equals 4.5. Now, the last thing I want you guys to do is find your vertex. Okay, now remember, your line of symmetry is always the x value of your vertex. You know that your vertex has to land somewhere over there. So I know that my vertex, the x value has to be 4.5. and I need to solve for the y value now. What do I do whenever I know an x value and I need to solve for my y value? I just plug it into the original problem. And the fact that the original problem looks like this, that's okay. I can still plug in my 4.5 in for both of those x's. So what is that going to look like? Let's go back down here. So now this is going to look like I have 4.5, I'm plugging this in for x, minus 3. And then I have 4.5 minus 6. And when I do this, I'm going to solve for the y value of my vertex. So 4.5 minus 3 is just 1.5. And 4.5 minus 6 is just negative 1.5. Then I'm just going to multiply those together, and y is going to equal negative 2.25. So again, if I want to write out my whole vertex, I know when I plugged in my x value 4.5, I got out my y value of 2.25. So this is my vertex. Then all you really have to do is just graph these points. And the only other thing that I'd have you do, since your y-intercept is so steep up there, I'm okay with you not even having to graph that. Just graph your two x-intercepts and your vertex, and that should still give you that nice symmetric U shape that we are looking for. Okay, let's do one more example. We have this one over here. We're going to run through the whole gauntlet of this again. So the first thing that we are going to do is solve for our y-intercept again. And remember, solving for your y-intercept means you're solving for y when x is 0. So the y gets to stay, everything gets to stay except for my 0, or my x's now turn into 0. So I have 0 plus 4 and 0 plus 1. Don't forget that negative on the outside over here. He's going to play a role in there. So now I have that negative still. 0 plus 4 is 4. 0 plus 1 is 1. Negative times 4 is negative 4. Negative 4 times 1 is still going to be negative 4. But again, it is not my y-intercept until I write it as an ordered pair. So when I plugged in 0, I got out negative 4. This is my y-intercept. The next ones now are our x-intercepts. So the x-intercepts, you're doing the exact opposite of what you were doing before. So x-intercepts. Now I am solving for x when y is 0. I want to know where it is on the x-axis. So I'm going to plug in 0 for y. And then, again, I'm going to use my zero product property. Now notice over here I have three things that are getting multiplied together because this is technically a negative 1 in front over here, but I can't set a constant equal to 0. And you guys should know that a parabola cannot cross the x-axis more than twice anyway. So when I'm using the zero product property, I'm only going to use it with these guys that actually have an x to solve for. So I'm going to set those two equal to 0, x plus 4 equals 0, x plus 1 equals 0. Going to subtract my 4 this time, subtract my 1. And then hopefully you guys see negative 4 plus 4 is 0 and negative 1 plus 1 is 0. So those are my two solutions to these. But again, if I want my x-intercepts, that means I have to write them as ordered pairs. So I have negative 4, 0, and I have negative 1, 0. These are my zeros. These are my roots, x-intercepts, all of those things. They are all interchangeable. Okay, so now I have my x-intercepts. So now I'm going to go in and solve for my line of symmetry. So remember, if my two x-intercepts are there, I want right smack dab in the middle of that x value that's going to cut these guys in half. So for my line of symmetry, all I'm going to do is add up my two x values together. Negative 4 plus negative 1, I'm going to cut those guys in half. I want to find the exact middle. Negative 4 plus negative 1 is negative 5. And negative 5 cut in half is just negative 2.5. But again, over here, if you want your line of symmetry, you want that vertical line that's cutting your parabola in half, which means I need x equals negative 2.5. That is my vertical line that will cut my parabola in half. Okay, then the last thing I need to do is just solve for my vertex. Let's remember to move the camera down this time. Okay, so my vertex, I know that my x value of my vertex is always on my line of symmetry. So over here, my x value of my vertex is going to be 2.5. I have to figure out where the y value is going to be. So remember, you are solving for y over here, and you're only plugging in that negative 2.5 in for x. So our original problem had a negative out in front. So don't forget to put that negative out in there again. And then we have a negative 2.5 plus 4. And then we have another negative 2.5 plus 1. So I'm just plugging in that 2.5, negative 2.5 in for both of my x's. Okay, then I just have to multiply all these guys together. So I still have that negative 1 out in front. I'm going to do my parentheses first. So negative 2.5 plus 4 is going to just be 1.5. And then negative 2.5 plus 1 is going to be negative 1.5. All right, so moving my camera down again, I already multiplied 1.5 times 1.5 over here, and I knew it was 2.25. However, make sure you're paying attention to this little negative out in front. So I have a negative times a positive times another negative. Those two negatives are going to be positive, and that positive multiplied by another positive is going to be positive. So now I'm going to get a positive 2.25. And again, when I plugged in negative 2.5, my output, my y value was 2.25. And now this is my vertex. So over here, when you go to graph all of these points, you should be able to fit them on a graph pretty nicely. So your y-intercept is negative 4. And then your x-intercepts are negative 4, negative 1. Your line of symmetry is negative 2.5. And your vertex is negative 2.5 and positive 2.5. Let's see if I can just sneak in a graph up here real fast. All right. Okay, so when I go to graph my y-intercept, I'm at negative 4, 1, 2, 3, 4. That's all the way down here. So always on my y-axis over here. My two x-intercepts were negative 4, 0, 1, 2, 3, 4, and negative 1, 0. Okay, so they are over here. And again, your y-intercept is on your y-axis, your x-intercept on your x-axis. My line of symmetry was right in between there, so at negative 2.5. So I'm just going to draw in my line of symmetry right over here. And when I plugged in negative 2.5 for my vertex, I got out 2.25. So that's right about here. The one last thing I want you to do, because I only have 4 points over here, I want to make sure my vertex is beautiful. My parabola is beautiful. I'm just going to reflect my y-intercept across my line of symmetry. So I'm just going to, it's 2.5 away from my line of symmetry. So I'm going to go 2.5 away from my line of symmetry over here. And now you should see my nice curvy parabola. It's running into my other problem a little bit, but that's okay. So you should have a nice graph like this. Okay, remember you're only doing 4 for credit, 4 for extra credit. So, and this will really help you with just developing those intercept skills. So I hope that you guys, if you have a little extra time, do take advantage of that extra credit. Have a great weekend. We'll see you guys next week.